Hello everyone, my name is Bruce and my roll number is 25109999078. Today I am going to demonstrate my 2P task for data structures and algorithms. In this task I have created two sort functions inside the vector.cs, inside the vector class where the program name I have declared is program.cs, which is the initial copy of the vector.cs. Starting from the starting, we can see that I have implemented Array.Sort, which passes all the functioning of the sorting function to it. Basically, here we using the Array.Sort to sort all the all the elements of the type or the sort all the elements of the list where we have passed the internal initial values such as we have passed 0 and it will count the length of the array. It will count the length of the list which we have passed, where because it is necessary because our vectors internal data structures we allocate some extra capacity or some has some unallocated memory which will be passed alongside data, so we need the count to ensure that Array.Sort only sorts active elements and ignores unallocated empty slots at the end of the array, and compare and uses the compare t default and uses the built-in compare t default function to arrange or sort all the elements in the ascending order. Furthermore, we can see that I have declared a sorter function which uses the IComparer, in which we have passed the IComparer list. It will sort the elements in the entire vector collection using this specific comparer. If the comparer is null, if it will check the condition if it is null, the order of elements is determined by the default comparer for t. Then it will pass. If it is null, then it will use this function. It will fall back the default. It will fall back it to the default comparer. And if else, if it is not null, it will use the custom comparer provided by the caller. Moving further, now let's compare the code difference between the IComparable and a IComparer. So these are the classes which I have defined. Here we have implemented the IComparer to provide default sorting behavior in ascending order, where it defines the object where it will define the object's single default sorting approach, which is by sorting element by their IDs. It will take the ID and sort the elements according to their respective IDs in the ascending order, and return the given parameter using the toString function. Given output using the toString function. Furthermore, there is a whereas uh, IComparer implements the comparer helper call like we have used in ascending ID comparer and in descending name ID comparer. It allows us to plug in custom external sorting strategies such as ordering by descending, which we have done in this class, or we can simply do order it by in ascending or in the default behavior, which we have done earlier. Then breaking ties by IDs without altering the original class definition. Moving further, we can see though that we have defined null checkers in both these classes. These null checkers I have used to these I have used in null checkers to evaluate null values before comparing objects properties. Basically, we use them as a guard logic to prevent applications crashing from null reference exception errors whenever sorting databases that contain missing or unassigned values. At last, I am going to show the working of this whole code by running this tester class by just simply entering the .NET run uh, command in the terminal. So here it is. It has passed all the tests from A to G. So I think that my run program is running correctly and passing all the tests. Thank you for watching the video.